You're welcome to today's class. Today we want to look at multi-dimensional arrays. We started the class on array and I've shown you one-dimensional array, right? We've looked at how to initialize an array, how to declare an array, and how to initialize an array. That is actually a one-dimensional array. Now, in one-dimensional array, you can access the elements using their index. I've explained that to you. But in C, when you declare a multi-dimensional array, you can equally access them using the indices. Now, what's the difference between a multi-dimensional array and a one-dimensional array? You have different types of multi-dimensional array, but in this class, I'm just going to show you a two-dimensional array, and then in the next class, I will show you a three-dimensional array. So we have one, two-dimensional array. Then we have three-dimensional array. We even have these two, this is three. We even have four, we even have five, right? But our word is a three-dimensional array. So we are just going to stop here in this C class. So today I'm going to show you two-dimensional array. Now, a two-dimensional array is like this, right? So we have 1, 2, 3. So the index 0, 1, 2, let's add 1, 3, 4, right? Then we have something like this. So 0, something like this, 1, something like this, 2. So I'm just going to stop there. Let's not make it too much. So let's not make it too much. Now, these are the index. So this is row, and then this is column, right? So this is row and this is column. Now, the syntax for a two-dimensional array is, let's write it here, data type, right? Array name, right? And then you have this for row, and then you have this for column, right? This is the syntax. So syntax. So this is the syntax for a two-dimensional array. So you have row and then you have column. Now, when you declare a two-dimensional array, this is mandatory. The column is mandatory, and I'm going to explain to you why it is mandatory. So example of a two-dimensional array is what I've written on the board, or I've drawn on the board, like your Excel sheet or like your chessboard, right? That's what you have. So I'm going to insert values into this two-dimensional array. So I'll put 1, 2, 3, 4, 5. Let's, so that it will not be too much. Let's leave it. Let's leave it here. 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is a two-dimensional array. If I was to write this as a one-dimensional array, it would have been like this. It would have been like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, this should have been it in a one-dimensional array. And then the index would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. That would be the index for each of the numbers. Now, this is how a memory is. A memory is linear, just one straight line. This is exactly how a memory is. So the memory address of this one will be what? I'm assuming 100. So you have it as this. If I'm to represent this two-dimensional array on a linear memory that is one-dimensional, how am I going to achieve that? That is the essence of this class. Before we even write a computer program, we need to understand how the compiler is going to insert these values into this place. Now, to achieve that, we are going to use a formula, which is what is called flattening. That is, we are flattening this to this. But to achieve that, you need to know the column. It's mandatory. So if we are going to define this array, if I'm going to write this array, it will be like this: int, let's just call it max, right? Let's call it max, or let's just call it matrix. Int matrix. Right? Int matrix. Then I told you this is row. So how many rows do we have? 1, 2, 3. So you have 3. Now, how many columns do we have? 1, 2, 3, 4. So you have 4. Now, this is the declaration of the array. Now, when you are declaring a multidimensional array, what you have inside this square bracket will be what? The complete size of the rows and the column. But when you want to access the element in the array, you are going to use the indices. So to access, say, this 12, it will be what? Matrix matrix. Then you are looking at the row. So which row is this? The index of this row is what? 2. So the column of this 12 is what? 3. Right? So this one will give us 12 as a value. So you have to understand the difference. When you are declaring an array, it is the actual number of the rows and the column that you insert into the square bracket. But when you are trying to access the element, you are going to access the element using the indices. So for row of this 12, it is what? 2. And then for the column of this 12, it is what? 3. That is how you do it. Now, how would the compiler know to insert this 12 in this place and then determine the address in order to have that constant time of accessing any of the values? This is how it's going to be done, right? If the address here is 100, what will be the address of 12? To achieve that, we need a formula. So the formula to achieve that is flattening index. So I'll write index, and then I will say I times j, I times column plus j. This is the formula we use to get the index. You know, for us to calculate the address of this 12, let me do this. For us to calculate the address of 12, we need base address plus I, which is the index, multiplied by what? Size of data type. This is how we are going to calculate the address. So if the base address is 100, Then how do we calculate this index? Now, we need this multiplied by the size of data type. It is an integer. This is an integer. When we declared it, is an integer. So integer is what? 4. But we need this I. To obtain this I, that is where we need this formula. So this I, right, that you have here is for the row. Why this J is for what? The column. So to obtain this I, we are now going to, I want to get the address of 12. So I will come here. The index for this particular row is what? 2. So I'll say 2 multiplied by what? What is the column? Now, in declaring this array, I told you it is int matrix. Then you have, for row, we have 1, 2, 3. 1, 2, 3. So you have 3. And then for column is 1, 2, 3, 4. So you have 4. So if this is the declaration of the array, it means column is what? 4. So we'll put 4 here. Plus, what is the index for this 12? That is 3. Now, this will now give us 2 times 4. That is 8 plus 3. And that will give us what? 11. So this is the flattening index that we've gotten here. Substitute it for this equation. So this will become 11. So 11 times 4 will give us 44 plus 100. This will give us 144. That is the address in the memory. So the address of 12 is 144. You can now do this to see if you are going to get 144. If this is 100, this place will be what? 104. This place will be what? 108. This will be what? 112, 112, 116, 120, 124, 128, 132, 136, 140, 144. You see? So with this equation, we can actually tell the memory address that the compiler is going to store the value of this index, value of this 2 dimension. So this is how you can actually flatten a 2-dimensional array to a linear memory, which is 1 dimension. Because to achieve this, you are going to use a nested loop. So array of array, meaning each of the outer elements represent an array in itself. So this is an array. This is another array. This is another array. So these 3 arrays together gives you what? A 2-dimensional array. So that's what I want to show you. So you have this as the memory address, right? Now, interpreting this mathematically, looking at mathematical language, how do you interpret this? What this is simply telling you is that I am here. I will jump 8 elements. That is 1, 2, 3, 4, 5, 6, 7, 8. I will skip 8 elements and I'll be here, right? Then this 3 is simply telling you that you will now move. So after jumping 8 elements, you move 3 steps. So in moving 3 steps, I will move 1 step, 2 steps, 3 steps. So I'll be here. So that is the language of mathematics. Don't forget, the 4 cardinal points of mathematics are what? Multiplication, division, addition, and subtraction. This. So the simple interpretation of this is that you are jumping 8 elements and then moving 3 steps forward, and it will bring you to what? To 12. So, but the index of 12 in a linear memory is what? 11. That's what we've gotten here. So that is the 11, how we got this 11. And then substituting it into this place, and then this formula will give you the address as 144. So the compiler has this equation in calculating the position of the element in the memory. So that is what I want to show you in this class. So in the next class, I don't want this class to be too long, so I'm just going to stop here. I need you to understand this. So in the next class, I'm now going to write a C program to actually print out this as a matrix on the screen or access any of the values. That's what I want to show you. I will show you in the next class. So till we see in the next class. Bye-bye.